Hello again. My name is TTJ Kepsi Richard. Welcome to my YouTube channel. Today, our discussion will be on discrete mathematics, and we have been looking at logical operators. Last, we said that we have four types of logical operators: conjunction, disjunction, conditional, and biconditional. I have a video covering the conjunction and the disjunction. I will indulge you to check it out on YouTube. Today, before the video ends, we'll look at conditional statements and biconditional statements. This will be a very interesting engagement, so please be my guest. So our first stop is a conditional statement. When we say a conditional statement, which statement do we refer to as conditional statement? Conditional statement is a statement that takes the form if P, then Q. So if you have any statement that takes the form if P, then Q, then that statement is a conditional statement. For instance, I have two statements on the board. P is I'm elected. Q is I will lower taxes. Then the conditional statement P that Q. So if you see this, that means the statement is a conditional statement, or this is a conditional statement. So it simply means that if I am elected, then I will lower taxes. So that becomes a conditional statement. So P is I am elected and Q is I will lower taxes. Then the conditional statement becomes if I am elected, then I will lower taxes. I hope you get that. The first aspect of any conditional statement, for instance, this one, if the first aspect, I am elected. The first aspect is called the premise or the hypothesis or the antecedent. So please take note of that. The first aspect of a conditional statement, it can be called hypothesis, antecedent, or the premise. Now the second aspect, that's I will lower taxes. The second aspect of a conditional statement is called the consequences or the conclusion. So please take notice of it. The first aspect is called the antecedent or hypothesis or the premise, and the second aspect is called the consequences or the conclusion. The next thing we'll look at is when will we know if a conditional statement is true or when it is false? Then the truth table for a conditional statement. So we say a conditional statement is only false. It's only false if the hypothesis is true and the conclusion is false. Otherwise, it is true in all respects. So this simply means that when the hypothesis is true and the conclusion is false, then the statement is false. The hypothesis can be true and the conclusion can be true, it will be true. Both can be false, it is true. Then the hypothesis can be false and the premise is true, is still true. I hope you get that. So let's look at the truth table. So if I am elected, then I will lower tax. So if the first aspect is not true, if the first aspect is true and the second aspect is false, then the statement becomes false. Otherwise, it is true in all respects. So let's look at the truth table. So this is the hypothesis and this is the conclusion. So when the hypothesis is true and the conclusion is false, that is when it is false. But it is true in all respects. Thus, if the hypothesis is false and the premise is and the conclusion is true, it will still be true. When the hypothesis is true and the conclusion is true, it is still true. When both are false, it is still true. I hope you get that. The next thing we'll look at is we'll look at forms of conditional statement and look at which of these forms is equivalent to the basic of a conditional statement. So basically, we have three forms of a conditional statement, and they are 1, the converse form. 2, the contrapositive form. Then 3, the inverse form. So remember, there are 3 forms: inverse form, contrapositive, and the converse form. So let's look at the basic. We said that if P is I am elected and Q I will lower taxes. And we said the basic, the conditional statement this means that if I am elected, then I will lower taxes. So the converse form takes the form if Q implies Q implies P, Q implies P, which means that if Q, then P. If Q, then P. So now let's look at how that will imply. So if Q is I will lower taxes, then Q implies P will be if, okay, it will be I will lower taxes. I will lower taxes if I am elected. I hope you get that. So the basic is if I'm elected, then I will lower taxes. Then the converse form will be I will lower taxes if I am elected. That means the Q will implies the P now. Now let's look at the contrapositive form. It takes the form negative. Remember, so we say it takes the form the negation of Q implies the negation of P. That's if not Q, then not P. So remember that. So that will be I will not lower taxes if I am not elected. So that will be the contrapositive form. So it will be if not Q, then not P. I will not lower taxes if I am not elected. The inverse form takes the form the negation of P implies the negation of Q. That's if not P, then not Q. So how would that be? It will be if I am not elected, then I will not lower taxes. I will not lower taxes. I hope you understand the 3 forms of a conditional statement. Now, we'll look at the truth table for all the 3 forms and see which of them is the same or equivalent to the basic form. So, we'll look at the truth table for all the forms of a conditional statement and see which of them is equivalent or same as the basic form. And that provides the basis for validity. So, we said that a conditional statement is only false if the antecedent is true and the premise is false. Other than that, or otherwise, so we say a conditional statement is only false if the antecedent is true and the conclusion is false. Other than that, it is true in all respects. So let's see the basic form. So you have PQ where P implies Q. That's the basic form. So it's only false if the premise or the antecedent is true and the conclusion is false, then it is false. Other than that, it is true in all respects. So remember that. Now let's come to the converse form. So the converse form is if Q, then P. So now let's copy the true value for Q here. So remember the true value for Q are false, true, true, false. And for the P is true, false, true, false. So immediately we do that, the Q become the antecedent and the P become conclusion. So remember, it is only false when the antecedent is true and the conclusion is false. Other than that, it's true in all respects. So we check where this is true and this is false, then it's false. Otherwise, it's true in all respects. I hope you get that. Now let's see the contrapositive form. So the contrapositive form, if not Q, then not P. If you remember that very well. So this means we negate the true value for the Q and write them here. Remember we said when a statement is true, then its negation is false. We look at that already. So now the negation of this, of P. So here we'll say it is true, it is false, then it's true. Then we negate the P2. Here will be false, this will be true, this will be false, then true. So this is only true, is false when the antecedent is true and the conclusion is false. Otherwise, it's true in all respects. So we check when this is true and this is false, then it's false. Otherwise, it's true in all respects. Now let's do it for the inverse form too. So the inverse form, which is if not P, then not Q. The inverse form is the direct opposite of the basic form. Is the direct opposite. So let's negate the true value for the P. So the true value for the P will be false, true, false, true. And for the Q, it will be true, false, false, true. So this become, remember, this become the antecedent and this become the conclusion. So it is only false if the antecedent is true and the conclusion is false. Otherwise, it's true in all respects. So we locate where this is true and this is false, then it is false. Otherwise, it's true in all respects. Now let's see which of them has the same true value as the basic form. So let's check for the inverse. We have false and there is true here. That alone shows that it's not equivalent. Now let's check for the inverse. The inverse, so we have false, true. That means it's not equivalent to the basic. Let's check the contrapositive. See, false, false, true, 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 true. They have the same true value in all respects. This shows that the contrapositive form of a conditional statement is the only statement that is equivalent to the basic form and hence provide the basis for validity. This means that a statement is only valid if it is in its basic form or it is in its contrapositive form. The inverse and the converse form is not valid statements. So we'll take some statement and we'll look at the validity of the statements. So remember we said that the only form of a conditional statement that provides the basis for validity is a contrapositive form. Any other form does not provide the basis for validity. So let's look at this question. It says consider the following statements. P is Frida is clever. Q, Frida is not a mathematician. So P is Frida is clever and Q, Frida is a mathematician. Frida is clever, Frida is a mathematician. And they say if P implies Q, state whether or not the following statements are valid. So P implies Q, then we have to locate for the statement that is valid. Remember, we say that if P implies Q. Then the only statement that provides the basis for validity is a contrapositive form. That's if Q, if not Q implies if not P. I hope you get that. So we just locate this statement, then we are good to go. Thus, if Frida is not a mathematician for the negation of the Q, then she is not clever. Just locate that statement and we are good to go. So let's check all of them and see which of them is valid. The first one, if Frida is a mathematician, then she is clever. So what does this statement? So if Frida is a mathematician, that's the P, that's the Q. So the A is that Q, if Frida is a mathematician, then she is clever. That Q implies P. So this is the converse form, is not valid. Not valid. So we can say that the first statement is not valid. The A is not valid. Let's look at the B. If Frida is not clever, then she is not a mathematician. So if Frida is not clever, that's if not P. So we can say if not P. If Frida is not clever, then she is not a mathematician. So if not P, then not Q. So this is the what? The inverse form. If you recollect very well. So also not valid. This is not a valid statement. Now let's check the C. The C. If Frida is not a mathematician, then she is clever. So if Frida is not a mathematician, that's the negation of Q, which is Frida is a mathematician. So if Frida is not a mathematician, implies if Frida is not a mathematician, then she is clever. The negation of Q implies P. Also not valid. That's not a contrapositive form, so not valid. Let's check the D. So the D will be if Frida is not a mathematician, so that's the negation of Q implies, so if Frida is not a mathematician, then she is not clever. That's the negation of Q implies the negation of P. And this is the contrapositive form, so is the only valid statement here. So the only valid statement among these statements is D. Thus, if Frida is not a mathematician, then she is not clever. All the statements are not valid. I'll put one more question on this so that you try to and check out which one is a valid statement and leave your answers in my comment box. So let's look at the second question. It says consider the following statement. Atta is bully. That's P. Q. Atta is a strong person. It says if P implies Q, state whether or not the following statements are valid. A. If Atta is a strong person, then he is a bully. B. If Atta is not a strong person, then he is not bully. Then D. If Atta is not a bully, then he is not a strong person. Please leave your answers of which of these statements is valid and which one is not on my comment box, and test where you are actually watching me from. The next thing we are going to do is that we look at biconditional statements. So next up is a biconditional statement. Which statement do we say they are biconditional statements? So a biconditional statement, this how we usually write it. That's P implies Q and vice versa. This means that P, if and only if Q. P, if and only if Q. So for instance, the P is Frida is clever, and the Q is Frida is a mathematician. Is a mathematician. Then the biconditional statement P implies Q and this vice versa will be Frida is clever if and only if she is a mathematician. So anytime you meet a statement like that, Frida is clever if and only if she is a mathematician, then that statement is a biconditional statement. And we say that a biconditional statement is true if both the hypothesis and the conclusion have the same true value. Otherwise, it is false. What do we mean? So we say that when both the hypothesis and the conclusion are true, then the statement is true. When both the hypothesis and the conclusion are false, the statement remains true. They becomes false if the hypothesis is false and the conclusion is true, then it's false. Or the hypothesis is false and the hypothesis is true and the conclusion is false, then it becomes false. As far as both are false or both are true, then the statement is true. So look at the truth table for a biconditional statement. So before we look at the truth table for a biconditional statement, I indulge you to like my video, share my videos, please comment. Your comment keeps me going. Then subscribe to my YouTube channel if you are here too. This will make my YouTube channel grow more so that I can share more mathematical content with you. Remember, we say that a biconditional statement is true if both the hypothesis and the conclusion has the same true value. Other than that, it is false. So let's check. If, let's say there we have this to be true, this is false, this is false, this is true, both are true, both are false. They becomes true when both have the same truth value. That both are true or both are false, then it is true. When both are true and both are false, then it is true. Otherwise, it becomes false. I hope you get that. I hope you get that. We'll end it here today. Please remember to subscribe to my YouTube channel, as I said. Until we meet again on Discrete Mathematics, my name is Tete Kepsi Richard.